Hey everybody, welcome to Entraz. In this video today we're going to be talking about BGP. Now we're going to have quite a few little videos here on, basically the initial configuration of BGP, kind of learning what it is, what are some of the, use cases for it, especially when you're looking at the difference between enterprise routing and switching and service provider. Because a lot of the times, well, in an enterprise network, you probably won't be running BGP unless it's something, like the internet edge. You'll have to, advertise routes to an ISP using BGP. So that is one of the things you might actually be using BGP for. However, as part of the the CCNP enterprise and getting into some more of the service provider concentrations, we want to talk a little bit about BGP. Way we can understand, at least some of the questions that might be on the exams or any other various information that someone might want to learn and understand about BGP. It's been my experience that for some people, BGP is like something they'll never ever look at and never ever touch. So depending on who you are and what you like to do and where you might work, like I said, you might not really use BGP all that much. But here starting out, we're going to start looking at BGP and its configuration. So you're going to see here, we're going to start out with 4 separate routers. 1, 2, 3, and 4. The addressing on the links will be apparent. As you're going to see, we have a full mesh between 2, 3, and 4. And then 1 is kind of off here by itself. There's kind of a good reasoning for why we're doing this. When we talk about IBGP, this is the internal border gateway protocol, and we're going to see how advertisements within BGP do not propagate past a single hop. In eBGP, we'll talk about that in our last episode as far as this BGP is concerned, but what we really need to understand is that in IBGP we're going to have a single autonomous system in 65,001. When we start doing eBGP, we're going to separate the 2 autonomous systems right here. So 2, 3, and 4 are going to be in autonomous system 65,001. And then router 1 will be in 65,002. So we're going to get a good look and understanding of IBGP in a IBGP holy environment, and an environment where we do have a single eBGP connection. Now further down the road we might have more than just 4 routers and multiple BGP autonomous systems, but for now we're just going to stick with this as we want to make sure it's pretty simple. So let me clear this off right here and we can get into the configuration. Now I am running Cisco's CML, the Cisco Modeling Labs. And just so you're aware, CML is a workhorse of basically a Linux template. You get it as, I believe, an OVF with the VMDKs and OVAs from Cisco.com, and you have to install it on ESXi. But it's really cool. We have 4 CSR 1000V routers here. We're going to take a look at router 1. I do have some of the configurations already done. So the 12 network is 1 to 2. Each loopback is going to be the /32 or host address of its router ID, router 1. Over here we have router 2, so we have connection between 1 and 2, 2 and 3, and 2 and 4. And of course 2.2.2.2 as its loopback. Over here on router 3, we have the connection between 2 and 3 and 3 and 4 with 3.3.3.3. And then of course 4, it's the same type of thing where we have connectivity from 2 to 4 and 3 and 4. I'm going to start off with, let's just say router 2 here because it's kind of the core. It's kind of the reflector of our environment. Now there's a lot of things we can do when it comes to BGP. I'm just going to show you a single piece of the protocol at a time. So for any of those CCNPs out there, yes, there's a lot more to what we're going to be doing right now. This is just kind of an intro. We'll get to some of the more advanced stuff as we move forward. So as you can see, we have our IP addresses already. If we come over here to configure terminal, we can configure router BGP. Now, if we look at all the options, we have ERGRP, ISIS, OSPF, and RIP as a few examples. For BGP, we have to specify an autonomous system number. Now, we can specify this in kind of like an IP address basis. So 1.1.1.1 could be, so in this case, like 1.1 could be our autonomous system, but we're going to be looking at some of the traditional numbers here. So the 65,001 we talked about before, R2 is going to be an IBGP peer of 3, 4, and 1. What we want to start off doing here is, well, what do we want to do with BGP? Now keep in mind this is a lab style environment for learning, so those are just some things that we may or may not do, but it's for learning. Do show IP interface brief. Now the first thing we have to think about is, well, how are we going to provide loopback connectivity to our routers? We can come in here and do the network 2.2.2.2, and then you have to specify the mask. Now there are a couple of other options here, such as backdoor routes, and BGP also takes into account the NLRI, or the network layer reachability information, and we can get into that a little bit later. Now route maps are something we're going to be doing a little later as well, because they allow us to kind of engineer and change some of the configurations on our network. Currently we're just going to be advertising or injecting certain routes into our network. So when we do the mask, we configure the mask here, and there you go. We're going to be advertising the 2.2.2.2 network. Do show run section router or BGP will give us the information on kind of what we're working with here. Now BGP has the ability to do more of a dynamic neighbor configuration, which we're going to be doing a little bit later, but one of the things you have to remember about BGP specifically, you have to specify the neighbor. So in this case, we're going to say, okay, what's our reachability? We're going to have a neighbor on, let's see, 12.12.12.1. That's going to be the IP address of router 1. So 12.12.12.1, and then we have a lot of options here. As a basis for BGP, we really just need to provide the remote autonomous system number. This is where IBGP and eBGP come into play. If you have a neighbor with a remote AS that's the same as your local autonomous system number, that's an internal or IBGP peer. If this was in a different remote autonomous system, such as 65,002, well then it would be an external or eBGP neighbor. For now, we're just going to have the neighbor, the remote autonomous system, and we're going to move on to router 1. But let's come back over here, section BGP. We're going to specify the network and the neighbor 12.12.12.2. Configure terminal, router BGP 65,001, network 1.1.1.1, mask 255.255.255.255. And then of course we have our neighbor 12.12.12.2 and the remote autonomous system 65,001. Now in case you're wondering what the network statement does, so the network statement takes information in the routing information base, or basically information that you already have. So as an example, if we do a show IP route, you're going to notice that we have the 1.1.1.1 as a /32 or host route that's directly connected. Because this route exists on this router, we do have the ability to advertise it out. If we do not have the network layer reachability information or RIB information about a route, you will not be able to advertise it. It has to exist on the router. So you'll also notice we just saw something that came up that said BGP level 5 adjacency change neighbor 12.12.12.2 is up. So if we come over here and do show BGP, you're going to notice that I have a route in BGP to 2.2.2.2. One of the big things to remember with BGP is there's a lot of table information here. Status codes. We have a asterisk. Basically, the asterisk asks us if it's a valid network. And then, of course, the caret, what is it? The greater than caret means it's the best route. The I also means it's an internal route. So having this internal route, we have to have a valid route. We can have many valid routes, but we will only ever have a single best route. So you may notice a little later on where we have multiple hops to a single network. What you'll notice is we only have that caret toward a single next hop. Now when it comes to BGP, what we have to be aware of pretty much right away is the local preference, the weight, and the path. One of the things we have to worry about when dealing with BGP is the path selection process. Now path selection is kind of tricky, and there's a lot of information to that, but to make it simple on us, there's a few things we need to remember. Weight is first, as you're going to notice here, weight. This is the highest weight. So you're going to notice on the local host, or the local route, we have a weight of 32,768, and on the learned network, we have a weight of 0. So all learned routes will always have a weight of 0. Now, I don't know particularly why this is. However, it's because that weight is Cisco proprietary, which means no other vendor is going to use weight. I mean, there might be some out there that uses it, but it's not one of the well-known required path vectors. So that will always be 0 on a learned route. And then we have local preference. Local preference, of course, you're going to see here, all learned routes have a local preference of 100. If it is a local route, well, there's not going to be a local preference. Once again, this is the highest local preference. Now, if we go down the line, we have weight, local preference, locally originated, AS path, and med. We like, love all our mothers. So I forgot origin. We like, love all our mothers. Weight, local preference, locally originated, AS path, origin ID or origin, and then med. Those are the, the basic 6 path selection options. Now it goes a lot more into that. I think there's like 15 different path selection options. But as far as, we're talking about CCNA and, lower level CCNP stuff, you really don't need to go beyond these 6. And we'll talk a little bit about weight and local preference when we start talking about pathing rules. So if we want to path engineer the direction of things, we'll talk about that a little later. For now, let's kind of finish up here. So on router 2, we only have the neighbor of 12.12.12.1. So once again, let's do show IP interface brief, and we'll specify neighbor statements for the other routers on our network. Neighbor 23, remote AS 65001. We'll do the same thing for neighbor 24.24.24.2. This will be remote AS 65001. So there you go. Now we have all of our neighbors configured. Let's do the same thing on router 3 and router 4. Alright, so you'll see we have our neighbor changes coming up. So let's just come in here really quick and do a show IP BGP summary. You're going to see we have neighbors of 2 to 4 and 3 to 4. So that's good. Router 3, show IP BGP summary. 2 to 3 and 3 to 4. And then of course over here on router 2. Show IP BGP summary. That gives us 1 to 2, 2 to 3, and 2 to 4. So we have our 3 neighbors on router 2. Seems like we may be good to go. If we do a show IP BGP, this lets us know all of the networks learned through BGP. You'll see here we have a couple of things such as, rib failures. And the reason why we have these rib failures here, as you can see, is because these routes are actually locally connected to router 2. One of the things you'll also see here is we have 2.2.2.2 still, next hop of self, network of 1.1.1.1. Let's try to ping a couple things, shall we? Alright, we're able to ping 1.1.1.1, 2.2.2.2, 3.3.3.3, and 4.4.4.4. We do a show IP route BGP, you're going to notice we have these 4 BGP routes. You're also going to notice what the next hop is for these routes. Now, considering we have these routes directly connected to router 2, of course they're going to be accessible because, well, the 12 network, the 23 network, and the 24 network are all directly connected. If we come over here, let's just say router 4, and we do the show IP BGP, you're going to notice we know how to get to 2, 3, and 4. That's it. 2, 3, and 4. Okay, how about over here? 2, 3, and 4. Okay, well, router 3 and router 4 do not know how to get to router 1. If we come over here and show IP BGP, you're going to notice that we only know how to get to network 2.2.2.2. So this is one of the things you have to realize with BGP as well. And if you ever ask yourself, well, why don't we use BGP across our entire network? Well, this is kind of the reasoning as to why. An IBGP learned route will not forward that route out to any other peer. So considering that 4 and 3 told 2 how to get to their loopback addresses, router 2 does not tell router 1 how to get to them. So that's kind of it, right? IBGP, it's not going to work. So one of the things that the BGP community and the writers have done is created this thing called a route reflector. So if we look at show run section BGP, let's go into the configuration for 65001. And just like in all of the other new IP protocols, we have address families that we can work with. In this case, I'm only using IPv4, and it's going to be unicast, which is the default. From here, we can specify a neighbor statement, which of course, let me do show run section router first, and we're going to have a neighbor. And as you can see, when you create the address family the first time, it adds the network statements and the neighbor activate statements to the address family. So from here, let's just say neighbor 12.12.12.1 is a route reflector client. And we're going to do the exact same thing. Do no logging console. No logging. No logging console. Well, let's see if we can get through this thing without being annoyed by logging messages. So anyway, address family IPv4. We have our neighbor statement already for 12.12.12.1. So let's come back through here. 23.23.23.2. Route reflector client. Specify remote AS or peer group commands first. Oh, too many 23s. There you go. Neighbor 24. This is also going to be a route reflector client. How the heck did I do that again? Alright. Anyway, so let's go back over here to router 1. Show IP route. Okay. Show IP BGP. Well, okay, I actually have the networks for 3 and 4 now. The next hop, of course, is going to be 23.23.23.2 and 24.24.24.2. But there's kind of a problem with this, right? We do show IP interface brief, exclude unassigned. Well, we're not directly connected to these neighbors. And that's one of the interesting parts of BGP as well, is that we do not know how to get to these networks pretty much out of the box. Let's try a show IP route, and you're going to notice that, well, they're not there either. And one of the reasons why we don't have them as best paths is because, well, we don't have the ability to get to the next hop to get to these addresses. So you'll notice, of course, that the route reflector gave us these routes, but what can we do to actually get to the routes? Now, there is a couple of options here. One of the things we could do, and I don't recommend this, but hey, you know what? It's your network. Don't let anyone tell you what to do, because they're probably just jealous. Router BGP 65001 network. Well, let's just type the network statement in. Do show IP interface brief, exclude unassigned. Network 12.12.12.0 with a mask of 255.255.252, which is a /30. Once that's done, you're going to notice that we have indeed put our gig interface 1 into BGP. So let's check over here, show IP BGP 12. We learned it, but of course it's local to us. Show run section BGP. We have our route reflector clients, so let's go over to 4. Show IP BGP. So you're going to notice now we actually have the ability to learn 12.12.12.0. The problem is look at the next hop. 12.12.12.1. So, yeah, even though we have it in BGP, that doesn't mean we're actually going to be able to get to that network because we have the whole next hop self issue. One of the other things we can do, and I'm actually a real big fan of this, is the redistribute connected command. Now, redistribute connected is probably something you won't ever do, especially in BGP, because, well, it's just not something that's typically done. Now, if you have not done address family IPv4 yet, you can do it under config router. Otherwise, you have to go into the address family to configure redistribute connected. You're going to notice we're starting to get other BGP routes, such as 2 to 3, 1 to 2, etc. So let's try to ping 12.12.12.1, and you're going to notice it is successful. The reason this is successful is because, well, what's the path to 12.12.12.1? You're going to notice it's known via BGP. It's a distance of 200 because it's an internal route. This is administrative distance. We got an update from 24.24.24.1. Of course, that's a route reflector. And 24.24.24.1. So this is the next hop. If we come over here to router 1, show IP route BGP, you're going to notice that we have the ability to get to all of them as well. So let's see, from router 2 to router 4. That would be that guy and or that guy. And we can get to them both. So BGP can work pretty much like any other routing protocol if you want it to. The only problem is you have to configure route reflectors everywhere, which, isn't really the case. I've worked with some people that love BGP and they don't mind doing this crazy stuff. So like as an example, if we do a show IP route over here on router 3, you're going to notice we have connectivity through here. And then on router 2, let's see, we want to get to 4.4.4.4. Show IP BGP topology 4.4.4.4. Apparently there's nothing there. It's kind of surprising, because we learned 4.4.4.4. Show IP BGP 4.4.4.4. Anyway, you're going to notice that we only have a single learned route. So we have show IP BGP 4444. It's learned through 2.4, or 24, I should say. If we come over here on router 3, show run section router. Alright. Now, apparently I have some of my peer group stuff over here on router 3 still. Alright, let's come in here to router BGP 65001. We're going to specify the neighbor statement for 23.23.23.1, and we're going to make this a route reflector client as well. You're going to notice that the neighbor adjacency went down. So keep in mind when you're doing a lot of these changes is you could take down an entire network if you're not careful. So let's take a look. So now you're going to notice we had a single BGP path before. 2.4, I'm sorry, router 4 gave us the information to router 4's loopback address. Coming down here, you're going to notice, considering we, configured a route reflector client on router 3, we now see 2 available paths. And it, of course, tells us what the best path is. Now, in this case, you're going to see here that it says best. On router 4, it's the best path. Over here, we also have router 3 as a valid internal path. So, as I said before, BGP can be a very complicated protocol, but once you start playing around with it a little bit and just start configuring everything everywhere, it gets a lot easier to work with. So yeah, that is pretty much it for BGP in a nutshell, so to speak. Router BGP, you have to specify the neighbor statement for each and every neighbor. Remote autonomous system is either internal, as in the same, or external, as in a different remote autonomous system. You can specify the networks to advertise, and remember, the router needs to know that route before it can advertise that route. And then, of course, the neighbor activate is typically automatic, but make sure it's there if you're running with address families. And, of course, the route reflector client is there because an IBGPer does not advertise past one hop. Once again, the 4.4.4.4, the 3.3.3.3, they advertised these to each other, right? 3 advertised to 2, and 2 advertised to 3, and 4 to 2, and 2 to 4. So because there's kind of a looping problem here, this is one of the big reasons why they say that BGP needs to be what's called a full mesh, or connectivity to every other router. The problem here, of course, is we have this, offshoot over here that probably shouldn't be there, but for the sake of this argument, it's there. So because router 2 is connected to router 1, they exchanged information as well. Since IBGP is like a TTL of 1, once it hits the next router, it will not propagate out. They overcame this by creating route reflectors. And in this case, I created 2 route reflectors, which allows R2 to have 2 paths to R4, and of course, routers 3 and 4 to gain access to router 1. Alright, yep, so that is basics of BGP. Keep in mind, once again, real simple stuff, not truly in depth. I mean, we're going on probably about 20 minutes on this already. In the, I can't remember, in the next episode, we're going to be talking about using the weight and local preferences, as well as policy-based routing, or PBR, using route maps to come in and kind of engineer a route solution within our BGP environment. So I hope you join me for that one, and we'll see you in it.